Testing the difference between means for dependent samples. A scientist claims that pneumonia causes weight loss in mice. The table shows the weights in grams of 6 mice before infection and 2 days after infection. At alpha equals 0.05, is there enough evidence to support the scientist's claim? Assume the samples are random independent and the population is normally distributed. Alright, the first step for this is to identify the claim and then state the null and alternative hypothesis. So for this one, the claim is that pneumonia will cause weight loss in mice. And we know that these are dependent samples because we're looking at this first group, which is going to be the weight before the mice were infected with pneumonia, and there are 6 mice in this group. And then we're looking at the weight after of the same 6 mice. So now we need to go ahead and determine what our null and alternative hypotheses are. And in order to do that, we need to look at the claim and see exactly what that means. And that means that D, the difference between the two samples, looks like this. D will be equal to weight before minus weight after. So in order to determine what that means is, so if we consider the mean of the differences, if the mice lose weight, that means that this value will be greater than 0 because the weight before will be larger than the weight after, which means that this right here is going to represent the claim. And since the null hypothesis is always a statement of equality, the opposite of this will have to be that it will be less than 0. So this will be the null. So our next step is to find a critical value t from the table. And one of the things that we need to remember is that this is going to be a right-tailed test. So we will find the critical value. And once we do that, when we calculate our t based upon the data, if it is greater than the critical value, then we will reject, and if it's less than the critical value, we will fail to reject. So let's go ahead and determine what the critical value is for this particular problem. Now, remembering that there are 6 mice in the sample size, so that means that our degrees of freedom, df, will be equal to n minus 1, which that means that n is equal to 6. So therefore that will be equal to 6 minus 1, which will be equal to 5. And we will also remember that our alpha is equal to 0.05. So we'll need to use the t-table that is in our textbook. The spreadsheet that I have attached in Blackboard has the t-table integrated in it as sheet number 2. So then you're going to look for your degrees of freedom, which in this case will be 5. And then we'll go ahead and we'll look for a one-tailed test at a significance level of 0.05, which means that our critical value will be 2.015. So which, if we go ahead and rough out the distribution, that means that up here is going to be T sub C is equal to 2.015, and anything above it will be our rejection region. Now the textbook recommends using technology, and you can use StatCrunch, but the spreadsheet that I've created for you will do these calculations fairly quickly. So what you want to do is you want to go ahead and left click the copy icon, and you want to copy that to the clipboard. So once you click that, you'll get something that looks like this. And then you'll need to use your Control-C key if you're running in Windows, or copy it if you're using Mac according to the Mac procedure. So if I do a Control-C, that will copy my table to the clipboard, and then make sure that you're in sheet 1 for your spreadsheet, and you're going to left click in cell A4 and then Control V, and you'll notice that it brings in all the values that were in the table originally. Now under N over here, you're going to have to type the number of pairs, which in this case is 6, and if you press the enter key, you'll notice that it populates the sigma D, the D bar, the sigma D square, the S sub D, and the T sub C. The T sub C in this particular case is going to be the critical value that you're looking at to compare to the value that you just obtained from the table. So let's go ahead and continue working in this particular problem. So as you can see from the table, D bar is going to be 0.95, and then S sub D is going to be 0.356, and we're going to round to 3 decimal places. So that means I'll put 0.356 right here, and remember to put 0.950 right there for my D bar. Then you need to go ahead and calculate T for this data set. Well, once again, this spreadsheet has already calculated that for you, and that's going to be this value right here, and that's going to be 6.5297, and we're going to round that to 3 decimal places, so that will be 6.530. And then we're going to decide whether to reject or fail to reject the null hypothesis and interpret the decision in the context of the original claim. So the first thing we're going to do is look at this value in comparison to the value that we obtained from the table. And we'll notice that this value falls firmly inside the rejection region. So therefore, reject the null hypothesis, since the null hypothesis indicates that the mice would either gain weight or stay the same weight. That means that the alternative hypothesis represents the claim that the mice would lose weight. There is enough evidence to support the claim that pneumonia causes weight loss in mice.